Yes, we did do this last year. This is less than 64% of change. Okay, so here's the reason why you'd want to know this. So, like when you go to Shields, like Yahir and I did this weekend, and you look at all the stuff there. Oh my gosh, it's expensive. Oh, I hardly ever shop there. And then you get people want Christmas gifts and stuff, and geez, like $70 for a sweatshirt. That's like outrageous. That's like my day's salary. Anyway, and so we're looking through stuff, and so this would be for percentages. Let's say you go and you look at something that's on sale. Okay, so a lot of times they have sale for Christmas. It's Christmas sales. Then you come back and guess what? It's regular price again. So what we're going to do today is we're going to find out the percent that it changed, percent that it went up, and percent that things went down. Yep. No, that was the tax and stuff. We'll talk about that like tomorrow. Yep. Percent of change is like, or you find what it changed, remember, and then you divide to figure out. We did that last year. No. No, you don't have to. Okay, well, we'll see. So a few definitions for you. Really, the only one you need to write is this. Okay, the really only one you need to write is this one on top. Percent increase, you all know what increase means. Goes up. Decrease goes down. That's why you don't need to write this, because you should know what increase and decrease means by now. If you don't, then you need to write it. Yeah, we were shopping for Jordan's brother for Christmas, and he likes Iowa State, so we went to the Iowa State section of Shields, and we're looking at some of the stuff. And there was really, really cool like pullover. I'm like, I really like that one. We should get him that. And it's like way at the top. So we spent like 10 minutes trying to get it down. Number one. I know. Well, we couldn't find anybody, so we had to try to do it ourselves. Jordan's like, well, let me put you on my shoulders. I'm like, I still can't even. Anyway, we ended up getting it down. And I'm like, oh, this is really cool. What's it cost? $80. I'm not buying that. It's not even for me. So, jeez, my gosh, and I can't believe it. And we all pay it. That's the thing. We pay for it. But does like Amazon have like Under Armour stuff and like does it really? See, the thing about that is Amazon, you have to go through a whole bunch of pages. I just want to look and say that's what I want. That's why people go shop at the stores, because they want the convenience of it. Could do that. I should look at that. Well, now you know, because maybe we can get stuff cheaper that way. Oh my gosh. Yeah, it's just outrageous, and we pay that stuff. Like even tennis shoes. I love looking at tennis shoes. Love it. But the tennis shoes I want are like an arm and a leg. You got them somewhere else? Dunham. They have good ones too. But that's good deal. Really? Oh, Amazon. I would trust Amazon, I think. Do PayPal instead. See, that's why you can't have the Amazon app. Like when I had Nolan and I was on maternity leave, like in the middle of the night I'd be up and I'd be like on Amazon, oh, buy. I'm like, oh, this is bad. Like, yeah. They're getting into a lot of stuff. Even Amazon's getting into like pharmacy stuff, I think, like medicine, and it's never gonna end. It's just crazy. Oh, like buy now, but yeah. Oh yeah. Do you have any of those? That you can get them off Amazon. They're like little things that look like this, and if you push them right, then it automatically orders it onto your account. Yeah. They can't push it again. Well, that's good. Yep. Well, I was even kind of watching. There's a commercial for Walmart, and it's like a Google thing, and it says, "Oh, add this to my grocery list." And people are getting bored talking about or listening to our shopping. Okay, so here's what you're going to use to find the percent of change today. So percent of change is going to be the amount of change over the original amount. And some people are like, what is the amount of change? That's the difference between prices. And usually, the original amount is the first thing that's listed in the problem. Always usually going to be the first thing, unless they have it stated different and it's a story problem. The first one is usually always the original. Okay, you got this written down? Okay. So how is this going to work today? They're going to give you a problem, and it's probably going to look like this. 57 to 89. That's like what it's going to look like in your book. And they're going to have you do two things. They're going to have you tell if it's an increase or a decrease. Well, if I look at this, if it starts at 57 and goes to 89, it's going to be an increase, okay? So it's not always going to be stated like this. Then the second thing it's going to have you do, it's going to have you find the percent of change then. So the first thing I'm going to do is I have to find the difference between these two things. I'm going to take 89 minus 57. In this case today, you always take the bigger number minus the smaller number. You're never going to have a negative, nothing, anything like that. It's always going to be the bigger minus the smaller no matter what position it's in. So 32. So 32 is my difference. Then what was my original? Yeah, so this is what it looks like. This is the difference. This is the original. Now you're going to divide them. Okay, just like you know how to do. The top goes in the house. And you only, for me today, let's say this. You need to go out 3 spaces and we'll round to the nearest whole percent. Okay, does that sound all right with everybody? We'll round, don't worry about what your book says, we'll round to the nearest whole percent. So if I start doing this, let's see, 57 times, I think it's 6, 2, 4, darn it, it's going to be a little too high, so let's try 57 times 5. 5, carry the 3, 55, 28. Is that right? No. Is that right? 285? Okay. Alright. 5, 285. Zero down. It's going to be a 6. That's 342. 8. Bring a 0 down. Okay, then I'm going to stop. You don't need to go forever. Then, you're going to make it a percent, because every answer is going to be in percent format today. So we're going to move it over 2 spaces, so it's going to be 56%. Let's just round all to the nearest whole percent today. We'll make it easy, okay? Any questions on how to do that? No, you got to go 3, because this third one is going to tell you what to do with this one. Yeah. So any questions so far? Okay, let's do a decrease one. Let's do this one. We won't worry about this then. So, first of all, it's a decrease, and what am I going to do? Subtract, very good. 20 minus 9, I get 11. Over, what's my original going to be here? 20, it's always the first one listed. 11 divided by 20. I subtracted the 2. Remember, I have to do that first. I have to subtract the 2 first, remember, for my difference. It's going to be 5. Yep. So this would be 55%. Not too bad, right? It's really not. To me, this is one of the easiest things to do with percents, but you just forget. You forget that, oh, it has to be the difference over that original. So So I'm going to go on a little bit here, and I'm going to skip this because I don't think that's on there. The next thing I'm going to talk about is percent of error. Okay, so what we just talked about was percent of change. Now we're going to do percent of error. So percent error is a little different than percent of change. Concept the same, but different things go in certain spots in that top and that bottom. So the only thing different with percent of error is this. This is the only thing that's different. Because before we did difference over the original, now this is the difference over the actual. So let's talk about this. So I think last year I used remember when you have like a thing of jelly beans and you have to guess how many are in the jelly bean jar? And you get a prize if you get the closest. So let's say Dylan guesses 300 jelly beans, but there's really like 350. Okay? So he guessed 300, but there's really how many? There's actually how many? 350. So you always use the actual for the below number, not the original amount that he guessed, the actual one that they're supposed to be. Okay? So that's the only difference between percent error and percent of change. So can I change this? So here's an example. Becky estimates that a charter bus has 34 seats. It actually has 45. I want to know what percent of error that she was off. What percent error did she have? So I would subtract. It's 11, right? 11 over 45, because this is the actual now. Difference. Okay. What's that? I don't know, is it? I know it's 290, 20. Is that 5? 4. It's got to be 4. 0, carry the 2. 180. Is that right? 20. It's going to repeat, and repeat, and repeat, and repeat, and repeat. So really, it's 24% she was off. Just quite a bit. Bad guess. Yep. Actually, I don't think that's too bad. With small numbers like that, yeah. 45 times 5? 5. Sorry. Yeah, that's right. That's okay. Why don't you do this one for me? Okay, this is a percent of error again, so you're going to use what we just talked about. So, this is like when a baby's born. This. Yep, no matter what. So, like, before you have your baby, they say, oh, we estimate it's about 8 pounds, but that doesn't mean they're right. I mean, it's like give or take a pound or 2, like, so don't even tell me what you think, how big it is, because it could be really 10 pounds or 6, so that's a big swing. So let's see, always subtracting. You always got to make sure you line up your decimals. Does it? It does come out even. All right. did. This isn't 121. This is 128. You think it's a 1. If you would have put an 8 there and made it actually look like your numbers are supposed to look, you'd have been fine. That's still wrong.
I know, I did it wrong.
What'd you do?
It's supposed to be 28.
What are you talking about? Oh, yeah. So did you get it? You need another second? Did you get it?
No.
What? Why not? Don't give up. Where's your numbers even at? This isn't even the right number. You didn't even subtract that right. Where do you go? 6.4. 1.6 is in the house. Okay, goes in 2. Where'd you get 102? Should go in twice. Be 128. Yeah.
My math is so off right now.
So it should be like 25%. Do I need to do that? Do I need to do it? Okay, last one I want you to do in your notebook. Pick one of these. I don't care which one you pick. You don't got to do both of them. You pick one. Pick one. Now we're going back to percent of change now. This isn't the percent error. This is percent of change. So back to what you know from the beginning. Those of you who are sneaking on your math today, this is your last one to redeem yourself with. Remember, round to the nearest whole percent. That's fine. The first one should look like 7 over 24. And this one should look like 15 over 54. Yeah, and like, so you can read them? So you don't think it's something else? That would be a good idea. If you're not sure, this is what they should start to look like. This is this one. This is this one down here. This one. Probably. Oh, you did all of them? Who? Who are we talking about here? Oh, I thought we were talking about Carver. I'm sorry. Don't look at me like that. It's an honest mistake. Okay, let's talk about this first one. What did you get for the first one? 20 something. Yeah, approximately 25%. Is it 29? Jeez. I'll go with what Rain said. First one? I don't think that's right. That's 29? Okay, what about this one? 25. Figure it out. I love that. 29.1, and the other one is... Okay, the other one be 27%. This should be 27. This should be 27%. Riley, speak up.